Classic David. He's mounting a square photo on the piece of card shown below. Not too sure what he's doing with it. Maybe it's a gift for his favorite maths teacher. Maybe it's going in his room. Who knows? But here we are. So we have this strapping young lad in a square photo. All right, and it's got a length of n minus 2 centimeters. Interesting. So I guess we don't know what n is, right? And it's mounted on card, so that has a nice border. Right? And we know the total width of the card is 2n plus 6. Alright. It's a constant width. Great, so it's not changing, which means n is some number. It can't be different numbers, right? It's not adjustable. Cool. And we're given the total area of the border. So the border area is this light gray area here, right? Or this dashed area that I'm marking out now. So that area is the total area of the card minus the area of the photo. So we're given that area. All right? And we're asked to find the width of the border. So when we're faced with a problem like this, right, we have quite a few unknowns, but we are given, well, the unknown being n, and we're given one bit of concrete information. That's the area of the border is 200 centimeters squared. So let's start by trying to use that information in an equation. So our first task is to find an expression for the area of the border so that we can then substitute in 200 and then solve for n. So area border, we just said was area of the card minus area of the photo. All right, so just putting it in English first so we know where we're heading. So the area of the card, which is a square card with lengths 2n plus 6, so that means this length is also 2n plus 6. So that area would be 2n plus 6 squared, right? Because it's a square, so the area is one dimension squared. And we subtract from that this square photo area, which likewise will be n minus 2 squared. Right, and the area of the border, so on the left-hand side of the equation, we know that that is equal to 200. So what we've done in that second line is we've used the information, right, the concrete information, and we've written it as an equation in terms of our unknown variable n. And so just looking at this, before even expanding and simplifying, I can tell that this will be a quadratic equation, right, with some n squared terms, which is great news for us because we have like 20 different ways of solving a quadratic equation. So let's go about expanding that out and solving it now. So 2n plus 6 squared, I'm just going to write it out in full. By full, I mean write 2n plus 6 two times, just so I don't forget to multiply out the middle terms. That's a very common mistake. So 2n times 2n, 4n squared, 2n times plus 6 plus 12n, 6 times 2n plus 12n, 6 times 6 plus 36. And now we have a minus sign. This little dash cost me, I don't know, too many marks to admit in all of my schooling and university life. So let's be careful, and I'll keep the minus sign. I'll expand these double brackets in here, and then I'll distribute the minus sign. So let's go n times n is n squared, n times minus 2, minus 2n, minus 2 times n, minus 2n, minus 2 times minus 2, plus 4. Now let's just group our like terms So 12n plus 12n plus 24n. You could have done that in the last step if you're confident with your arithmetic. Plus 36 minus bracket n squared minus 4n, grouping the minus 2 n's. N plus 36. Alright, so here, if I distribute the negative sign, I mean we'll get negative n squared. So it's technically negative 1, if you want to think of it like that. Negative n squared. Negative times negative 4n is plus 4n. Negative times plus 4 is minus 4. Alright, and that was a bit over precautious, but better safe than sorry sometimes. And now we can group like terms some more. So 4n squared minus n squared is 3n squared. 24n plus 4n is plus 28n. 36 minus 4 is plus 32. Great. And now, okay, we do see quadratic on the right-hand side, but to solve it, we want the quadratic to equal 0. So I'll subtract 200 on both sides. Minus, what is that, 168. So we have a quadratic equation. You might be a bit more familiar seeing the 0 on the right-hand side, but exactly the same thing. Right, where we have A, B, and C. Where A, B, and C are just the coefficients of our quadratic equation. So now let's solve it. So you could complete the square if you like, but I'm a bit lazy today, so I will use my calculator, which is perfectly fine in an algebra exam when you get to a stage like this. However, if the question was like factorize or solve by factorizing, then you have to show you can factorize. But here, let's just save some time. We hit menu, go to EQUA, equa for equation. The type of equation is a polynomial, F2. It is degree 2. That means the highest power is 2, so it's a quadratic. And see at the top there, ax squared plus bx plus c equals 0. That is exactly what we have, right? Where our a term is 3, the number in front of n squared. Our b is 28, execute, and our c is minus 168. There we go, we hit F1, which is solve, and we get n equals 4.1525, or n equals minus 13.49. Yeah, let's round those both to two decimal places. There you go. So we worked out what n is. So pat on the back, good job. So got this far, that's looking at a merit. But how do we secure the excellence? By answering the question. So we didn't answer the question yet. We need to find the width of the border. So looking back at our problem, the total width of the card minus the width of the photo leaves us this distance here, the sum of those two, right? And so if we half that, we will get 1 border width. So let's put that as an expression. So the border width is equal to half of the card width minus the photo width. Right? So again, card width minus photo width leaves us twice the border, so then we half it. So let's write in that real quick. Border equals half 2n plus 6 minus n minus 2, I think it was. Yep. So that will become 2n plus 6 minus n. So 2n minus n is n. Minus negative 2 is plus 2, so that's plus 8. Right, have we found the border width? No. Right, we need to substitute in n. Now we got two solutions because we had a quadratic equation, so that's what we expected. But in this case, for a distance, we will disregard the negative solution and take our positive solution and substitute it in for n, which is 4.15 plus 8 all divided by 2 gives us about 6.1 centimeters. Whew. All right, just to recap this one because it was a long one. We had two squares. We were given the area of this border, so we found an expression for that area, substituted in the unknown dimensions in terms of n. We then grouped like terms, simplified, and the key step was boiling it down to this quadratic equation. So we could then solve, in this case on GDC, equa, solver, right? And then we disregarded the negative solution. So disregard as negative distance. Right, so just saying something like that next to it is totally fine. Or justifying why you took the positive one. And then we substituted that into our equation for the border width.